Hi, my name's Fiona French, and I work in the School of Computing and Digital Media at London Met University. My co-authors are Clara Mancini and Helen from the Faculty of Science, Technology, Engineering and Maths at Open University in the UK. The goal of our research has been to design and develop some novel technology-enabled enrichment for captive elephants. Why? Because elephants are social and smart, usually live in large herds and communicating with each other continuously. But as we know, things can be a bit different in a captive situation, where strict routines are inevitable. Space and social opportunities may be limited. So, we've been trying to design some interactive devices that elephants can use to control features of their environment, providing them with cognitive and sensory stimulation. But how to go about developing a system that would engage an elephant? As well as experiencing the world at a different scale from humans, elephants rely on different senses and have different physical capabilities and psychological motivations. So, we took a research through design and craft approach, hand building multiple versions of enrichment devices and testing them with elephants over several years. This is our main tester, Vali, who lives at Scandervale Ashram in Wales. As we progressed, we became increasingly aware of how the aesthetic dimensions of each device affected how the elephant interacted and whether she was interested in playing with it, and how her aesthetic sensibilities differed from our own. We know that an elephant trunk can be compared with a human hand in that it's used for caressing, combat, feeding oneself and others, investigating novel objects and manipulating tools, but it's also simultaneously a sensory organ, a nose and a sound producer. Elephants' olfactory and auditory senses are very sensitive. We considered trying to design aroma into our enrichment, but everything we made was smelly enough already. Smells we could neither perceive nor regulate. We deliberately chose to avoid food associations so we could tell if the devices had intrinsic appeal rather than being related to foraging behavior or fitness. It seemed to be important that devices were visible, so that elephants could notice them as new objects in the environment. However, one of our testers, Lakshmi, is blind, and yet once she'd first discovered a new toy, she would return to it again and again. Since elephants more often use smells and sounds to navigate their world, we weren't too concerned with visual aesthetics. As our output, we did a lot of experimentation with sound synthesis, as well as using short samples of instruments and other animals. We were very conscious that playing human music to an animal has limited chance of success as an enriching activity for many reasons. Now, our early prototypes were essentially switches, different versions of binary on-off controls. The elephants seemed to enjoy feeling those wooden frames, touching all round the edges and stroking the different materials we used, probably smelling them too. But everything was static. The buttons had to be robust and bolted securely to the fixtures. Push buttons weren't pushed, so we had to use hidden sensors to capture all the trunk tip interactions. However, we felt this was covert and actually went against our principles of giving more control to the elephants. Additionally, it probably meant that mapping the input to the output wasn't immediately apparent to the animal. In order to allow the elephant to express acoustic preferences, we needed to create an analog control, something that could provide a graduated response, and we wanted to make this control pleasurable to use as well as easy to understand. The aesthetics and the affordance had to work together. We based the design on a slider. Sliders have obvious boundaries that are both visual and tactile, as well as a thumb or handle that protrudes, tempting the user to touch it. Even a light touch will move the thumb along the track. And we hypothesized that a slider would both solicit action and facilitate the learning of itself. So we made one by repurposing an old drawer slider and mounting it in a wooden frame. We used infrasonic sensors embedded in the frame to track the slider position using an Arduino, and we used an old scrubbing brush for the thumb, chosen for texture and smell. The slider movement was mapped through the microcontroller to volume and tone of an auditory output, which we synthesized. When we first installed the device, neither elephant, Vali or Lakshmi, showed much interest, but video footage revealed that later the evening, when everyone had left, they both played with the slider, and they continued to interact with it after I left, after the audio component had been disabled. We traditionally think of having 5 senses, perhaps a 6th intuitive sense, but recently there's been an upsurge of interest in the kind of pleasure that is experienced from physically doing something, a kinesthetic or performative, embodied sensory experience. We find this to be particularly relevant in a more than human context, since we assume that most other animals experience life in a holistic fashion, not separating signals into scents or sounds or bumps or glimpses or flavors. Indeed, performative and tactile aesthetics are very important qualities for a device aimed at elephants. A device that affords a pleasurable experience is much more likely to meet its enrichment goals, since the design will encourage the animal to play with it. More fundamentally, our exploration has enabled us to develop aesthetic sensibilities that a human-centered perspective might fail to appreciate, but which more than human-centered design demands. So we'd like to thank all the elephants who tested our devices and all the keepers, carers and experts who gave their support and evaluation and encouragement throughout this project. Thanks very much.